In this video, let us continue our character setup. We have pretty much all the character animations done. Our character can walk around. We added a sprint feature. We learned how to use a state machine instead of just directly running the animations in the animation blueprint. And now they can also play the shoot animation, which only plays on the top half of their body. We also added a particle effect, so our animation blueprint now also communicates back with our blueprint on this event shoot to play the spawn, to spawn this Niagara particle that just kind of gives us those spark effects. So let's continue on and let's actually create the logic, the basic logic of our shooting system. To do that, we are going to use a ray trace. We are going to draw a straight line from our player going forwards, and when this hits any enemy, that we'll know that we've hit the enemy, and we can do something on the enemy. We'll work on that later. First, let's just get the player shooting properly. So to do that, again, we're going to use a ray trace. We are going to trace a line from our player. To get the ray trace started, we're going to use a function called line trace by channel. This is the same function. It's very similar to this. To our get hit result under cursor. You can see that this line trace from the cursor returns a hit result and a return value. This hit result contains a bunch of information about the thing that we just hit. Same thing here. It returns a hit result. It's called out hit, and a return value. Did we hit anything or not? So let's plug that up. We need to decide on the start and end locations, but before we do that, let us first add a branch node here. And only if our return value is true are we going to continue, doing stuff. We also want to set this draw debug type. Let us set it for 1 frame. So when we shoot, we should be able to see that line pop out. Now let's think about the start and the end locations. I want this ray to start from my player, so I'm going to start it from my actor location. So get actor location, and our ray is going to start on this actor location. So that would be the center of our actor, and we want it to shoot out. We could start the ray on our muzzle, but because our animation's going to be like, waving the gun around and everything isn't kind of set well, it's not made to be, these actors aren't made to work together like these models and animations. We won't get quite accurate shooting, so let's just shoot it from the player's body. And I think for a twin stick game where we're top down, this should work just fine, which is why we're going to shoot it from our actor location. And we want to shoot it from our actor location. We want to shoot it a certain amount forwards. So we can get actor forward vector. We can multiply that by some number. It can be a float. But before we actually multiply it, let us normalize it. The forward vector usually comes in normalized, but it's good practice, to know that we should normalize things before we do it. This way we can just multiply it by a float, and I'll just multiply it by something large right now. And all we need to do is add this to our actor location. So this now represents our actor location plus some forward vector added to it. So it's going to be a distance away from our player. And we'll set that as the end. Now this is very convenient because this event shoot runs on our animation. If we find the shooting montage, it runs here where we have our special notify here. We have our special notify that goes the anim notify shoot effects, which is going to call our BPI function on the pawn. And that's going to run here. And we want to run this code, every time we shoot as well. So there's a convenient spot to do it. So we have our debug showing. Let's just go see this in action. Now you can see when I shoot, there is a little line that pops up for a single frame in front of our player. So we have our player, well, shooting. This is really the logic for shooting. We just have to, cast this line out. And really, the next bit is if we hit anything with this line, we want to be able to test that hit. And then if it is an enemy, we're going to be, doing stuff with it. So let's start off by making an enemy class. I'm going to make a new folder for this in content. Call it enemy. And let's make a blueprint class for it. For the enemy, we are going to make a character class as well, because the enemy, just like our player, can control this pawn, and the character class comes with all the movement that we need. So the enemy can, or the AI can also use these functions to move around. Makes it very simple. The character class isn't just for the player, it's also going to be used for our AI. So let's make a character, call it BP enemy. So open them up, and let's get a visualization in here. So I'm just going to go into Mixamo and find a character. I am going to use this character here, Crypto. Just make sure we select them, and then we download them in T-Pose. When we have them downloaded, let us just import them into our game. So I'm going to import the enemy here. And we want to make sure they don't have a source skeleton. We want to make sure this is set to none so that it imports and uses its own skeleton. There you go. And I'm just going to make a folder for this, call it Crypto. Let's put all this stuff in here. Okay, then we can just, for this mesh component, like we did with the player, just add Crypto in and make sure we set them to the right rotation and scale and location. Awesome, I think that looks just fine. Now we need to make sure in our BP self, this BP enemy self, we go under our collision settings. And we need to make sure we can generate overlap events, and we can simulation generates hit events. We need to make sure that's checked because our line trace outputs a hit, so it's a hit event. So we need to make sure that our enemy, the collision, the simulation will generate those hit events, so our hits will count. Lastly, if we look down our collision preset, you can see the visibility trace channel. It's ignored currently, but our line trace is using the visibility channel. So let us just set our mesh, our collision preset to custom, and let us block the visibility component so that when we hit the enemy, it actually registers it because it is blocking things on this trace channel, which is the channel that we're going to use. That's the visibility channel. Finally, I'm just also going to give the enemy a tag so that we have some way of identifying them from other things. Call them enemy. Compile, and we want to go back to our twin stick pawn. So let's break this out hit first, and you can see there's a bunch of stuff here. The first thing we're going to do, we're going to check if our hit actor has tag, and we called it enemy, and if that's true, let me move all of this just a little lower. If that's true, for now, let's just print a string. Let's say enemy hit. Let's compile it, go to our level, and let's just add some enemies in here. So let me just drag some BP enemies. Great. Okay, so we have a bunch of enemies here. We can see if we hit them or not. So we just run the game and check. And you can see it doesn't hit, doesn't hit. If I go over them, we hit them. Great, and that was as simple as that, setting up some shooting logic. Now we actually have our player shooting. They hit the enemy. They can well, we haven't had the interaction with the shooting yet. The enemies don't like die or do anything. That we'll set that up a little later. But we got the basic shooting done. The last thing I'm going to do real quick, the shooting, just to make it look a little nicer. Right now we have the muzzle flare effect, but if I was to turn off this debug and run it whenever it responds, we could see that I can't really tell where I'm shooting. Of course, some of it is the fact that the animation's a little wonky and the gun placement's a little wonky, but we can't really tell where we're shooting, right? So let us add a little effect in just to visualize that. We're going to add a little tracer in there. I do want to brief that this is not really the best way of doing this. Ideally, we do all of this inside a particle system, inside a Niagara system, but I don't want to go into making that kind of particle. It's fairly, it's not complicated, but it's a lot of new concepts, and it's, you know, not really a part of this class, but I do want to make this look a little nicer so we can actually get some feedback on our shooting, and we're going to do that in a very simple way. Inside my twin stick player, I will just make a new blueprint class, an actor, and I will call it BP_tracer. And we're just going to keep spawning this tracer. It's just going to be some actor. We're going to spawn it whenever we shoot so that the tracer moves forward. So we can, to this, we can add a projectile component, projectile movement. If you were making a gun that didn't use hit scan, which is a type of weapon we are using, it's called hit scan because we cast a ray and whatever it hits, well, we scan it, we check its tag, and we do stuff on it. It's instant. There is no travel to it. If you wanted to make a gun that uses projectiles, you would make a separate actor like this, call it, give it a projectile movement, and just as we're going to do, we're going to be spawning it. But instead of doing all our calculations, like all our enemy calculations on this hit, you're just going to do a collision event between this projectile and this enemy. So this now this projectile would have the code on begin overlap. Am I colliding with enemy? Do whatever. We're not going to do that. I'm going to use this just for some visualization. So to this, I want to give it some visual, and very simply, I can add a new Niagara system. And we're just going to use this dynamic beam preset. We're not going to do anything to it. We're just going to add this preset as is. And Niagara systems have the prefix NS for Niagara system. And I will call it NS, I don't know, beam. Let us add this Niagara system in here. And let's call it NS beam. And then in the event graph, I am just going to give it a delay of maybe, I don't know, 3 or 4 seconds, and just destroy the actor. This way, we spawn it, it goes flying somewhere, and, you know, we don't need to see it ever again. And in the projectile movement component, let us make sure to set its velocity, X, Y, and Z. X is the forward axis, so let's set that to something high, so like 1,000. We can again test it, and if we need to increase it, we can increase it. Now finally, in our enemy, when we do the shoot event, before we even do the line trace, because we want to fire this projectile whether we do a line trace or not, we are going to spawn actor from class. Let's make sure we run it. We're going to select that class and make it BP, what did I call it, tracer. And we're going to use our actors transform. So get actor transform, and let's plug that in here. So let's go check this out. That works. It's a little slow, so let's make it like much quicker. Back in our tracer, make this go up maybe another, you know, a factor of 10. So there you go. Okay, now we have some feedback. When our tracer goes over an enemy, our player knows they've hit them. Awesome. So that was it for this video. We have just set up the very basics of it. I'm going to break this up into maybe 2 or 3 videos, not too sure. In the next video, let us get our enemies moving, and then maybe in the final video, let's actually get when we shoot the player, the enemy dies, and when the enemy touches us, we die. Thank you for watching.